Hello, Algebra 2 scholars. We are going to be doing skill 4.1, which is the beginning of exponential functions. So in all of Unit 4, we are going to be focusing on exponential functions. And what we kind of notice about exponential functions is that the slopes get steeper and steeper, and they will escalate, just like it says here in this meme. And if I'm kind of like drawing the slopes, if this were like some type of treadmill or mountain climbing, the slopes would get steeper and steeper as I kind of like drew these red lines. So the basic format for growth and decay type of functions with exponential functions is we have a times 1 plus r to the t for growth, where an exponential growth function obviously is getting bigger exponentially. So your slopes are getting steeper and steeper in a positive direction. So the a value represents initial amount. So that could be like how much money you put in your retirement account, or how many people are in Indianapolis today, or how much chemical do you have in moles or something like that. The R represents percentage in decimal form. And T represents kind of our unit of time. And the decay function is almost exactly the same equation, except you're going to do 1 minus r to the t. And the decay graphs start high, and then they get like lower, and their slopes actually kind of flatten out as you go to the right. So make sure you got this down, because I think these are very important to give you for your basic growth and decay. So why do we care about exponential functions? Well, it is good to see how they compare to a linear relationship. So in Algebra 1 class, what you did was you plugged in your numbers to find your y value. So your input was your x value. So I could plug in 2, for instance. So I could do 3 times 2 minus 6. So my output would be, in this case, 6 minus 6, which is 0. And we can actually see that the difference between the outputs is constantly the same. So if I were to kind of do the same plugging in over and over again, I would see that the function goes up by 3 every time. So note that the slopes are the same. Now, unfortunately, the transfer of this example into the PowerPoint did kind of affect things. This should be 2/3 times 3 to the x. And actually, the output on this one is going to be 2. Because this is 2/3 times 3 to the 1. But if I wanted to find with the 2, so I'm just going to kind of rewrite this, 2/3 times 3 to the x. And if I were to go to my calculator, that's 2/3 of 9, basically. So that's going to get me 6. So in this case, I multiplied by 3. And I'm going to bet you that if we go to the calculator and do 2/3 times 3 to the 3, that would get you to 18. And we could just times 3, and we're just going to times 3 again. So your slopes are kind of like being multiplied by 3. So if we say quotient, we could actually say product or quotient in this case. So then let's see, 18 times 3 is going to be 54. And then I could do times 3 again. And I'm going to do 54 times 3. And that's going to get me 162. So some of your delta math exercises are going to be seeing, is it linear, is it quadratic, or is it exponential? So if you kind of see that the slopes are being multiplied or divided, it's going to be a exponential. And I'm just going to kind of add the word product in here as well. All right. Here's another table question here. First thing I would do is I would kind of think about, is there a constant linear rate? And in this case, I kind of see that I'm doing a plus 10 every time. But because I'm doing that and because I'm adding the same thing each time, it's going to be a linear relationship, because the difference, or I guess we could also say sum of consecutive output is exactly the same. So my output goes from 10 to 20 to 30 to 40 and so on. So we're looking at the output relationships and not the input relationships. So assuming that the input goes up at the same rate, we are looking at the output. Here's some other examples. And let's see, this one, it says, explain whether the situation is modeled with a linear or exponential. One thing that is a dead giveaway that you are dealing with exponential is the percent. And why don't we actually kind of introduce this percent? So if I gave you the amount of water, we could call that A. And if it's decreasing, I could do 1 minus 0.04. And it's each year. So it's going to be to the T. Now, the college tuition, cost of tuition, man, those are like the good old days. It's probably more like $2,500 a year now, or something like that. But each year, this type of language is a giveaway that it is a linear, and that it would fit a y equals mx plus b. And then this is also, this is probably like an SAT type of question. But when you have a number that is being exponentiated, and it's called exponential because the variable is in the exponent. And we'd say that this is an exponential type of situation. So in the next skill, we're actually going to play around a little bit with these exponential functions and see how they work, and kind of talk about how we can use the equations as well.